Welcome. In the previous videos, we learned the idea of mole ratio that you can do, and then we reviewed the idea of balancing equations. Now, this is really the only comprehensive video on this particular topic of limiting excess that I want to do. So I want to keep it all in one video, so it's compact, and that's all you pretty much need to know as far as limiting an excess goes, right? So we will look at one more problem where we would talk about one of the reactants being excess, but that's not the case here. Assuming that you have this chemical reaction that's shown, and you have 30 grams of one reactant, which is benzene, and 65 grams of the other reactant, which is bromine, and I'm asking how much of the product, one of them is shown, is produced. Okay, this is usually the way this particular question is written. And if the question does not explicitly state that one of the reactant is excess, this is the method you would use, irrespective of what the chemical reaction is. Right? Now, typically videos on YouTube on this particular topic is fairly long, so I've tried to condense it and keep it very short, so you just get everything you need in a short piece of video. With that said, as always I've said, the equation would rarely be given to you in a balanced form, but looks like this particular case, the equation is balanced to you. So if you balance it, it looks like it's 1, 1, 1, 1, right? Now there was a purpose, because I want to keep things simple to start off with. So first, what you have to do is to figure out which of the two that you have reactant is limiting. And the way you do that is first start with benzene, and the given information, as I've always said, goes in the top left corner and the top cell on the far left side, and put a 1. First, to go to limiting, you got to go from grams to moles, and the only way you do that is through molar mass. And the molar mass of benzene is, if you do the math, it's 78 grams over 1 mole. Now, what do we put on the top and what do we put on the bottom? Well, we know we need to get rid of the grams, so we put the grams, moles at the bottom. Now, this is the most important step and probably the most critical step in the process, and that is the mole ratio. Now, this is for benzene, right? Now, that means the moles, the coefficient of benzene should always go here, and the mole ratio, the coefficient of the product that we're specifically interested in. So right now we're comparing these two, right? So that's 1 to 1. So we put 1 mole of C6H5Br, that's equal to 1 mole of C6H6, because those are the two numbers in front of those two. Now let's get a number here for this. So it'll be 30 over 78 times 1 over 1, which will be 0.384 moles of C6H5Br, right? Now we're going to compare these two, because this is a product, this is the other reactant, and we know we're starting with 65 grams of Br2, right? And again, put a 1. And each Br is 79, so Br2 is 79 times 2, which is about 158 grams over 1 mole, right? So that number goes here, and this is 1 mole of Br2. Now we look at the coefficients of Br2 with respect to that, which again turns out to be 1. So 1 mole of Br2 and 1 mole of C6H5Br. What are we really trying to do is find out where do we get, I'm going to write this again because that's what we're trying to do. So 65 over 158 is 0.411 mole, roughly. Whichever number of this two is smaller, you do the same math with respect to this particular product. That's what we're comparing each of our reactant against. So you do this math and you figure out which one is the smallest. That means this is the smallest value, and which reactant is giving that smallest value is the limiting reactant. Keep in mind, we're calling it limiting reactant. So that means C6H6 is limiting reactant, right? And that means the other reactant must be excess. So Br2 is excess. So now what do we do? How do we actually find the amount of this product that's made? It's very simple. All you do is take whatever number that you identified as the smallest, put it in the top cell, put 1, because there's nothing there, and multiply it by the molar mass of this product that we're interested in. And if you do the molar mass of this, it's roughly about 72 plus 6 plus 79. 79, that's about 157 grams over 1 mole. So 157. So basically you take the smallest of the two value, multiply by the molar mass of the product you're interested in, whatever that product might be, times 157, sorry. So that'll be 59.1 grams, something like that. Okay. This is called the theoretical yield. This is how much the maximum, if you were to carry out, you can produce. And that's all the question is asking. When it's asking how much of it's produced, it's asking for how much is the maximum you can produce. This is the maximum quantity, and that's usually referred to as the theoretical yield. Now, I have done this. Say you carry out this reaction and you actually only produce 20 grams. You see that what actually means this corresponds to experimental. Okay? It's asking what is the percent yield. All you have to do is, there's a formula for it. It's actual over theoretical times 100%. That's it. So that means you take the 20 gram, which is the actual yield. That's experimental. Theoretical yield is what we calculated in the above, multiplied by 100%. So that'll be 20 over 59.1 times 100. So the percent yield is about 34%. And that's it. Does that make sense? All right, let's keep going. The last one is calculate the amount of excess left. We've identified our Br2 is excess. So how do we actually go about it is you take the limiting mole, okay? So take the same limiting mole, 0.384 mole, okay? Multiply that by the molar mass of Br2, which is 158 grams. So keep in mind, you're not taking the mole that came from the Br2. Again, you're taking the least of the two value, multiplied by the molar mass of the excess reagent. That's all you're doing. What does that give you? 158 times 0.384. It's 60.6 grams. Now what is this? This is not what is left. You have to subtract it from, to actually find the gram of excess, you have to take the 158 that you started with, or sorry, 65 grams you started with, right? Minus 60.6 grams. Okay, it's usually tempting to not subtract this from the 65. So you might see a choice on the answer for this particular question to be 60.6 and you think, oh yeah, I got it. No, you got to take that extra step. You actually started with 65 grams, of which so only 60 has reacted. That means you're left with, let's do the math. Again, I'm doing fraction, you can just do, it's about 4.4 grams is the excess that's left. And if I calculate the total time of the value, it'll be about, I don't know, less than 10 minutes, I would say. So this is how you do a problem with calculating first theoretical yield, calculating percent yield, and calculating the excess left, all right? There's only three things all that will change in a problem, which is why I've given you a practice problem, is the mole ratio. The system is exactly the same. So here's what I want you to do is, here's the chemical reaction, here's the question, and I ask you to do 4 different things. Calculate the theoretical yield. Just tell me what the limiting reactant is. That means other is excess. I want you to calculate the percent yield, and I want you to tell me how much of the excess reaction is left in terms of grams. And that's it, and I'll wrap this video up. So you want to go through this problem, understand it, just don't memorize it. It's very, very simple. I've explained the rationale on why we did each step. So you don't need to memorize, and then work this problem out. And that's it, and you're good to go. So stay tuned.